Welcome everybody. Welcome to my talk, Deep Dive into gRPC. First of all, I would like to thank you all for choosing this talk because I know there's a lot of good talks happening at this time, so thank you for choosing this one. Also, before we start, I need to share something with you. Although it is called Deep Dive into gRPC, it originally was supposed to be a tutorial session, but because another tutorial session of mine was basically also accepted and they told me there can be only one. This became regular sessions. So I will not go as much into details as I would like because we don't have like 2 hours, we have only 45 minutes. Come on. Yeah, all the things that I'm going to share with you basically come from my own personal experience, so it might vary differently for you. First of all, let me introduce myself. My name is Vladimir Dejanovic. This is my Twitter, mail, GitHub account, and blog if you want to follow me online or contact me online. I'm a part of professional scene since 2006. In other words, I'm getting paid to develop software since 2006. And I worked on all kinds of projects, all kinds of programming languages, tools, frameworks, basically, you name it, I did it. It's basically like a lot of stuff. Also, I'm a founder and leader of AmsterdamJUG user group. And also I speak at a lot of conferences. And I'm Code 1 star. But enough about me. What this talk is going to be about. First, I will be talking about gRPC. What is gRPC? Then I'm going to spend basically some time explaining, okay, what are the good use cases for gRPC, where we can use it, and for what we should use it, for what we shouldn't be using that. And then we'll go basically to the deep dive as long as basically time allows us. If you have any questions, please wait until the end and basically ask them then, or you can always contact me in person after the talk, or ping me online on a Twitter or mail. I'll be more than happy to answer any question. Okay, so what is gRPC? Well, if we go basically to the official website and look for the definition of the gRPC, we're going to find something like this. Come on. gRPC is remote procedure call. Okay, but what the first gRPC stands for? Well, gRPC, remote procedure call. So it's basically like a loop, it's recursion of the name. In a nutshell, it is remote procedure call with a lot of goodies baked into it, and that's more or less everything that we need to know. And to be honest with us, yeah, remote procedural calls are not a new thing. They have been present with us for a very long period of time. For example, if we're staying only in JVM land and basically all the clients and the service and everything is in JVM, we could of course use RMI. Or if basically we wanted to have interoperability with some other programming languages, for example like C or some others, then we, in this case of Java, we had to use Cobra. And we all loved Cobra, right? Well, to be honest with you, I never used Cobra, but I know that a lot of people were happy when the Cobra was kind of killed. As with any remote procedure call, basically we have a service, and the service has some procedure that can be called remotely. And in this case, the service is written in C++. Then we have one or more clients, right, which can actually call this remote procedure remotely, right? And in this case, the clients are written in 2 different programming languages, and especially different programming language compared to the service. And the reason for that is because majority of the RPC frameworks are language agnostic. So you have like implementation is in more than one language. If we talk about gRPC, basically with gRPC, a lot of things are taken care of for us. So like I said, there are a lot of goodies baked into it directly, and and we don't need to worry about them. The way that actually the client calls the remote procedure call is done through the async messages. So basically the client is going to send the message asynchronously to the server, and is going to basically make the whole payload of all the information the server needs in order to process this remote procedure call. Then, if all is good, the server is going to do its work, and it's again asynchronously going to send back message to the client, and again send the whole payload, this all the information and results of this remote procedure call. In case that there is some error happened during the during the calculation of the numbers, then the server will actually inform the client about the error. The good thing about all of this is that all these communications, sending messages, sending errors, all these kind of things are taken care of for us by gRPC. We don't need to worry about it. We only need to worry about, what's the business logic? What happens if basically I send a message and there's like success? Basically, how do I deal with that? And what I do in case of error. Everything else is taken care of by gRPC, so it's not our problem, which is a good thing in my mind. When we talk about gRPC, we have to say that, again, it's language agnostic, but it doesn't support, at the moment, all programming languages. At the moment, out of the box, it supports C++, Java, Python, Go, Ruby, C#, Node.js, Android Java, Objective-C, PHP, and Dart. And I was at one conference and asked, like, for every language, is there anybody there? And like, for every single language, somebody raised their hand. So that's a very diversity bunch of people. What I would like to actually stress here are these programming languages, because if we take them into account, then all the native development for the mobile applications is covered, and majority of the basically backend systems are covered. So I would say that we're in a very good starting point with the gRPC. Okay, so you can ask yourself, okay, but where should I be using gRPC? What's the use case for gRPC? And let's be honest, that's a very valid question. And whenever I learn about some new technology or some new language or something like that, that's the first thing that I ask myself. Okay, where should be I using this? Where I shouldn't be using this? Because in the end, we developers are, like small kids with a new toy. Whenever we get some new programming languages, framework, or tool, or whatever, we want to use it everywhere. We want to solve all our problems with it. We want to go to bed with it, and have like nice dreams. But then reality kicks in, and we figure out, okay, like maybe this isn't really the best thing for all the solutions and all the problems that I have. So that's why I always like, try to think, okay, where should I be using this and where not? Well, in the case of gRPC, if you have, for example, a monolith, right, and you want to take your beautiful monolith, which you maybe love or hate, and take it from this state, right, one single entity, right, to this state, a lot of microservices which are actually talking to one another. How can you do this? Well, you can use REST, you can use SOAP, but also you can use gRPC. And using gRPC in this case is a very straightforward process and a very good process, because if you think with a monolith, basically you had a lot of method calls which are internal, right, in your code. And here with gRPC, you can just basically make those method calls be called remotely. And again, gRPC is going to take care of most of things for you. So basically, you don't need to really change a lot of your code base and everything, for example, that you would have to do if you go with the REST. However, be advised that gRPC at the moment can't talk to the browser. So if any of these boxes, little boxes, need to talk basically to the front end and to the browser, that part can't be done in gRPC. You have to go with the REST or something else. Another use case that, I changed already to this one. Sorry, my laptop is there and the slider is here. So another use case, very good use case that you can use for gRPC is actually when you have to build some very complex and distributed system where there is a lot of moving parts and all those kind of things. I haven't spoken about the history of gRPC, but gRPC actually came back from the Google, and they're basically knowledge and experience from building distributed systems, and I think that we all can learn a few things from them, and also some other companies. So again, a lot of pain points, a lot of the problems that we can encounter during building the massive distributed systems like fault tolerance, and all kind of things, are already taken care of. They're built into it, and also like Google is not the only company which add value to the gRPC. There are a lot of other companies which are also using gRPC a lot. And again, adding their own experience and knowledge into it. So they're taking care of for a lot of problems for us, and we just need to think about the business logic. But when I mention this, logical thing can be, yeah, but I don't work for Google, right? The problems that I'm solving are not on that scale. So should I be using then gRPC? Well, let us look one simple example. So let's assume that we have a user, some user A, and this user A wants to transfer money to user B, right? So of course, because we all know that we just can't give the money to other person because the government wants the tax, right? We have to use a bank. So how will we then do this? Well, user A will basically send to the bank, okay, I want to transfer money from my bank account to account of the person B. Then the bank is going to send the money to the account of the person B. And of course, we would like to get some feedback back. Did it succeed? Did I have enough funds? Did I actually send to the right person? Did everything went well, right? So imagine that you need to actually build the bank system in this case, and the client has a service. How would you do this? Well, you can do, like with REST, for example, but then you have to think, okay, which resources do I have? How do I actually, which resource is it transferring the money? Which status code I need to use, especially in the case of an error or some problem. For example, not enough funds, wrong account, or maybe bank can say, you know what, you're transferring a lot of money, I want confirmation that you are really you and not somebody who hacked your account, So solving that kind of problem with the REST kind of is not really intuitive, you know? You can say, okay, like, yeah, maybe like we can use SOAP. Well, yeah, that can also be approach. But again, in this case, using something as a gRPC would be a very natural fit. And again, a lot of things would be taken care of for you. The only thing that you need to do is add business logic. Okay, so let's now try and go to the deep dive of gRPC as time allows us. By the way, if I talk too fast, you know, just yell at me, you know, because I want to like cover as much. But again, it's more important that you actually understand what I'm saying than cover everything. So one thing that we need to be aware with gRPC is that gRPC is very opinionated. You know, there is one way working with gRPC, and as long as you say, okay, like I'm going to basically do as gRPC actually thought that it should be done, everything is going to be very easy and very straightforward. Again, there are hooks for you to actually, you can plug in certain things into gRPC and basically do certain stuff. Again, where the people who built gRPC thought that you should have hooks. So as long as you're basically okay with their vision, you're in the perfect place. If you want to fight it, well, then, you know, good luck. The starting point, of course, for gRPC would be this official website where you can actually go and read more information about, okay, what's gRPC, nuts and bolts, and all kind of things. Another very nice thing about this website is that there is a lot of documentation, guides, and everything that you actually need to start with the language of your choice. As I said, gRPC is language agnostic. These are the languages that it supports at the moment out of the box, so you can just go there and basically read all the things that you need to read. In my case, I'm going to use Java, so basically I'm going to go to gRPC/Java, and again, there are like examples how actually I need to build the client, how I can need to build the server, and all other things which I need to actually get started. I mentioned a little bit about the communication, right, between the client and the server in gRPC, and that there are some messages going around. Well, there are 4 types of communications that we have in gRPC. So the first thing that can happen is the client sends single message to the server. Server basically does its job and then sends single message back. Then what can happen also is that the client can send single message to the server, and then the server can actually send one or more messages back. The third way is that the client can send one or more messages to the server, and the server can send single message back. And I think that you probably already guessed the 4th type is basically the client has sent multiple messages to the server, and the server send multiple messages back to the client. And that's it. They're all 4 types of communication that we have. So any type of problem that you want to solve using gRPC, you just need to think, okay, which type of communication I need in this part. And there, again, there are examples how to build server and client side in all programming languages for all these 4 types of communication. Okay, so let us look a little bit more now into internals of gRPC, what actually gRPC consists of. gRPC consists of 3 big parts. First part is basically the protocol which is used for sending all those messages across. So we need some protocol, right? By default, protocol which is used is protocol buffer free. You can use other protocols also, but if you don't change absolutely anything in your implementation, by default you're getting protocol buffer free, and I would say it's a very good protocol. So I don't have a lot of time to actually cover it in all details, what the protocol buffer free is. So if you have more details, you should just go onto this blog and basically you can read it. In a nutshell, what we need to know is that the protocol buffer free is a binary protocol. So which also helps a lot with the through output, because as we know, if something is binary, we can send more data through the wire. Other thing that we need to be aware about the protocol buffer free is that it has tight schema. So basically we have a schema where we will define all the messages that are going one way and the other way, how they're going to look like, which fields they have, which type of the fields they have. And in my mind, that's a very good thing, because it means that protocol buffer free is going to make sure that the validity of a message is correct before we start doing any processing. So you can think of it as like XML schemas, you know, XSD in case of XML, you know. System is going to take care of that whatever you actually get is valid and according to the schema before you do any kind of work, which means that the things that you need to do in your code are much less. You know, you don't have to like worry about all the cases. Do I have the field? Do I don't have the field? And all those kind of stuff. If you don't want to read the blog post, you can also watch this video. I know this speaker; he's a very good one. So you know, and also again, this like very basic thing about protocol buffer and you know its internals. Okay. So one thing that I actually want to point you out here is that, you know, as you can see, the protocol buffer free is much better than JSON, right? Or maybe it isn't, you know? So first thing first, whenever somebody shows you any type of graph, be very critical. First of all, how they actually made the graph, what the point that basically they want to make, and how actually they came with the numbers. What are the numbers here? So the numbers that I'm showing you here are completely made up. However, the point that I'm trying to make is completely legit. The first one actually shows the output of the data that basically you can send across the wire. And if we think about it, okay, JSON is a plain text, protocol buffer is binary protocol, so it shouldn't come as a surprise that we can send more data using the binary protocol, right? Fair to say, if we zip the JSON and we do some other fancy stuff with it, the difference will not be that big. This one is kind of slightly different. And this one actually shows the CPU usage, during marshalling and unmarshalling of the data. And again, this shouldn't come as a big surprise, because in the case of JSON, it's a plain text, there is no schema, so you need to really go and crunch a lot of numbers to actually marshal and unmarshal the data. It's not an easy task for a computer. In the case of protocol buffer, it's a binary protocol, it's tightly defined with a schema, every field where it's coming, what type it is, so you know exactly how long it is. So marshalling and unmarshalling of the data is very fast and easy. Again, to be fair with you, if I care only about my laptop, I wouldn't really be worried that much about this thing here, But if you think about your users who can maybe be on the device, which is not CPU powerful like my laptop, for example, mobile phone, this really means a lot. Because if your application is CPU heavy, you will drain the battery, you will have basically bad user experience for your user. Again, if you have a big data center and you have a lot of messages going back and forth, you're going to spend a lot of CPU cycles on just marshalling and marshalling the data. And if you're paying your bill per CPU usage, then it also take this into account, because you're going to pay less. And I think everybody wants to pay less. Okay, the second big part of the gRPC is HTTP2. HTTP2 comes to gRPC by default. You don't have to do anything with it. For example, in the case of the Java implementation, it's and that comes embedded in it. And not only do we get HTTP2 for free, but we also get all the benefits for it. So we get higher throughput. We have basically both sides can be able to talk at the same time. And again, I think you can see here the theme. Protocol buffer free is good with throughput. HTTP2 is again good with throughput. And if you have a very huge distributed system, you might be sending 1 million messages per day, So if you send only 1 byte more, it's 1 million bytes more, So it should be as efficient as possible. And that's why I said a lot of goodies are already baked into it and take care of for us. The third part of the gRPC is IDL, and that's basically interface definition language. And as I said, gRPC is really opinionated, and there's one way, gRPC way. And when it comes to the gRPC, it's schema-first approach. So not only that we have to have a schema, but we first have to have a schema. First we write a schema, and then everything else. And again, from my point of view, that really sounds as a very good approach. Because again, if you have let's assume we have two teams. One team is basically building the client, other team is building the server. If you write first the schema and then you give to the both teams, okay, this is the schema, this is how your communication looks like, then both teams can just go and do it at their own pace. Nobody is waiting for anybody. At the end, when they both finish, they just come together and everything will work as long as they follow the schema. If there is some problems, it's easy to see, okay, who violated the schema and who didn't really follow the contract. So if we go back to this simple example, right, we were saying, okay, we have user A, which is sending money to the user B. Let's think how can we actually solve this problem from the gRPC point of view. So here we have a communication, right, where I say, okay, user A, say to the bank, transfer money from my account to some other account, right? And I want to get information back, did it succeed or not? So this is very simple, one-to-one message, right? On the other side, we have a user B, which is basically logged, for example, on his mobile phone, and he's just doing his own job, doesn't know about anything, that money is coming. So in that case, he would just want to get all notifications about the changes on the balance account, right? So it's basically one-to-many communication. But like I always say, talking is boring, so let's look at the code. So here, basically, I just created a very simple application using Maven architecture. Archetype generator, so it's very plain application. So I don't have anything specific for gRPC. So the first thing that I want to do is actually fix all the tests. Where's the lead? Anybody see the lead? Yeah, thanks. So first we delete the tests, right? Because we don't need tests. So what you're going to do actually, if you're doing the gRPC like I said, you're going to go to GitHub, gRPC/Java, and here basically you have one very nice dependency. You just do copy, you go back to your project, you go to your POM, and dependency, I don't need to JUnit anymore, right, because I deleted it, you add this. Then the next thing that you need to do is, again, there's like here a build one. Again, you just do copy, and let's just remove this one. Okay. And that's it. You're now ready to actually do everything with the gRPC. So what you need to do is basically here create a directory, proto. And then in the proto, we need to create a schema, because it's schema first, right? So let's call it bank. Proto. Is it proto or gRPC? Ooh, I forgot. Yeah, it's proto. OK. So the first thing that we need to define is basically the syntax. And we're going to say protocol buffer free, which is actually proto 3. Then we need to define the package. Because all the things that I'm going to actually write here, messages and things like that, the protocol buffer, basically gRPC is going to generate the stubs for me. So I need to say, OK, to which package to put it. And it's easier if I just say package, example, IT shark, conf.doc. Then one thing that you can add is option, and say Java multiple files equal true. Otherwise, by multiple. Oops. Okay, I have a typo. That's not fun. Oh, yeah. Oh, thanks. So Java multiple files equal true. And what this is going to say to gRPC is, OK, don't put everything that you're generating in a single class, just put in multiple classes. So we want to transfer money, right? So we need to define the message. So let's say define the message. Let's call it transfer. And what we need, well, we need int 32 ID, which is equal to 1. Then we need account that we want to transfer to. So let's call it, OK, no, it's not. Int 32, account 2. Let's say put 3, int 32, account from. Equal 3. So from which account you want to transfer money to which account you want to transfer money, then also we need to say amount, right? Example, amount 4. By the way, all the fields are optional. So in the protocol buffer free 2, you can put like some fields to be required, but in the protocol buffer free, they made everything optional. And then we also want a message. So we say message equal to 5. And that's it. So I defined my message actually to be transferring the information across the wire. So the next thing that we actually want to say is, OK, what's the message back? So I say message, transfer response. And again, we can say int 32, ID equal 1. We can say string message equal 2, right? So that's it. So now we have both messages. OK, let's enable import. So the next thing that now we need to do is basically define the service. So let's say service, and let's call it bank. And we can call it bank. So we say RPC because it's going to be remote. Call it transfer. The message which is coming is transfer. And it's going to return transfer response. Response, yes. So far all good, right? So the next thing that I need to do actually is to actually build the code. So, oh no, it's not this one. It's in C, yeah. Okay, it's this one. So let's just build the code. And why I'm building the code is so basically then the gRPC can kick in, take my schema, and generate all the boilerplate code for me. I'll show you that in a second as soon as this one is done. Okay, so if you go back here, what we're going to see here now is in the target directory, I have generated sources, and I have this protocol buffer free, and I have here one directory Java and one directory gRPC Java. So I think here is going to be my messages, if I remember correctly. So you see, here's my transfer report, response. So I need to actually mark this as a source root so that IntelliJ needs to know what to do. And also I need to mark this one because here is the service, again, as a source root. OK, so that's done. Now let's create a client. So let's create transfer client. Let's create main, public static void main, string procs. Okay, so the first thing that we need to do is actually manage channel, manage channel. And in gRPC, you use builders for everything. So we'll use manage channel builder for address, well, localhost, right? Localhost, yes. Port is going to be 8080. Then I'm saying use plain text. The reason why I'm using this is because I'm on development machine. HTTP2 by default comes with HTTPS, and I don't want to be bothered with that while I'm doing the demos in development. But in production, you use HTTPS. And we say build, and that's it. Now we need to actually create a client. So we say bank, gRPC, and then here we basically have options for 3 clients. We have a new, basically blocking stub, future stub, and a new stub. By default, everything that's happening in gRPC is asynchronous. However, client can choose if it wants to be blocking or not. In this case, I'm going to be a blocking client because I don't care. I provide the channel. And we put this one, then say client. If I know how to type. Okay, I say client, create local variable client, okay. And now I have a client, so now I can actually invoke remote message. So let's say just client, transfer, and here I can say transfer. Again, new builder, so we need to set some values here. So set ID, let's call it 1. Oh, it's not big ID, it's small ID, right? Yes. Then set account from, let's call it 123. Let's say set account to, let's call it 456, right? 445, okay. Set amount, let's say 42, right? That's a good number. Set message. Here is money. And we build it, and that's it. And we're going to get back a message, so it's going to be response. Critical variable, yes, response. And what we're going to do with response, well, we're just going to syslin, right? Println, and we're going to see response. Okay, so client done. Now we need also to create a server, right? So let's create a server. Let's call it code1 server, because it's cool, right? So again, let's create public static void main. So we have a server, gRPC server. Server is, again, server builder. So everything is builder. For port 8080, right? 8080. And then I can say build. And I say servers.start. And I say server.await termination. I need to await termination because I'm starting the server in the main thread. So if I don't, basically it's going to just, stop and kill my server right away. So we already did everything, So let's just run it. So let's start the server. It's fast, right? Just wait a few seconds for it to compile. Okay, so server is started. It doesn't print anything, but it started. And if we go to the transfer client and we call it, we can also run it. What do you think? It's going to crash? Oh, it crashed. Well, of course it crashed because I didn't implement the transfer method, right? Okay, so let's kill the server and let's now actually see how we can implement the transfer RPC. Well, we do that by calling add service, and here we say new or my service. Let's call it my service. Service impl. Okay. So let me just copy this. Let's create new class, and so this is basically how dependency injection works in gRPC. You just say add service, and you basically add the instance to be injected. That's it, very simple. So the one thing that I need to do here is I need to extend bank gRPC bank impl base. And basically this one done again all the boilerplate code for me and all the kind of things. So I can again start it, but again, it's not going to work because I still need the transfer method, response procedure call. So this is way how can actually to figure out what you need to do and how actually what's the signature for a transfer method that at least I use is I just open this one and I say find transfer. And here it is the transfer, and then I just copy paste. Again, I'm a very lazy person, so you don't have to do it like in this way, but for me it works. And that's it. So let me just clean up this a little bit more so it's easier to read. So basically the transfer, I get the transfer method, right? As basically the first message, which is what the client is going to send to me, and basically I have something else which is called response observer. Well, so this one here, transfer, is the message that I get from the client. This one here is something that I use to actually send response to the client. And again, like I said, in gRPC, everything is async, so this is also going to be asynchronous. So for me to actually send a response, I just need to say response, observer, and here I have onCompleted, onNext, and onError. So what's happening is I want to send a message back. I will call onNext and provide the message. If there is some problem that happened, I will going to call onError and provide the error. And if everything finishes and everything is done, I'm just I'm going to say onComplete. So because I want to send the response back, I'll call onNext, and it's transfer response, new builder, and let's put some values here. So set ID, well, we're going to send a request, get ID, and then we're going to set message, and let's say all is good. And we're going to take the message from the get message, yes. So, okay, I have an error. Okay, now all is good. So, if you see here, what I can do is say response, request response, and I say again on next. So I can send multiple messages back, because from the service point of view, it doesn't know if the client expects only one message or more. However, please don't do that, because if I send multiple messages back to my client, I'm going to crash my client, because my client expects only one message. So in my case, I'm just saying on completed, and that's it, I'm done. So let's go quickly and see if actually all works now. So let's start the server. Come on, run. Okay, so server is started, so if you go to the transfer client, we call the transfer client. Okay, I get some errors because of Java 9, but okay, it works. Cool. Okay, so let's look basically now the second part, where actually we get the notifications, right? So first, let's build the notification client. Okay, so again, let's add static void main. Arcs. So again, I have managed channel, right? Managed channel. Channel is managed channel builder for address, localhost, right? Localhost, port 8080, localhost, right? And say use plain text and build. Cool. Then we need again bank. gRPC. This time I'm going to use non-blocking service. I'm going to basically use asynchronous client. Okay, channel. Come on. Okay, say client. So in this case, I'll also need one small helper. So just here, public static void, no, static boolean. Boolean. Yes, should work, equal true. And let me just come here and say while should work thread sleep 500. So I'm going to do this because again my client is asynchronous, so if I don't do this, it's going to just kill my main thread and kill my client. So I'm going to say client. And then I'm going to, oh yeah, I didn't have notification. Wow, I'm too fast. So first I need to actually add a message for notification. So let's first add message account. So I would just want to say like int 32 account for which account I want notification, and then I get back message notification, and notification is going to be for account equal 1, and going to be double amount, so amount equal 2, and string message equal 3. So as you can see, I can basically use the message inside the message. So basically you can create whole basically classes and everything, like we would do in Java. And now we need to create notification RPC. So let's create RPC, notification. We get account, and it returns notification, right? And that's it, right? Well, not quite, because if I just made it like this, then it's going to be like one message back, one message forward. We want multiple messages. To do that, we just basically add one keyword, stream, and that's it. And now it basically knows, okay, it's going to be multiple messages. Okay, I need to actually comment this one. So I again need to recompile my code to get the new helper methods, basically package, basically the classes and the client and everything, the boilerplate code, so to say. Wow, we're very short on time. Okay, so now I have a client, so I can say client, and now I can say notification, and I say account, and I say, oh no, new builder. Account new builder, okay, and set account 1, 2, 3, right? And that's it. And then the next one, also what I need to provide is new, basically this one. And this basically says, okay, like when I get a notification, actually, when I get back the messages, what should I do? Well, in case of next, I'm going to just print it. Notification. And if I get uncompleted, I should just say should work equal to false. And also I'm going to do that on error. Should work equal to false. And that's it. So the client is done. Okay, so how we actually do the service? Again, we go to my service simple. Basically, let's find the notification. Okay, here's the notification. Let's copy paste this one. So I'm adding override. Okay, let's just add it like this. And from our notification point of view, well, it's not going to be really very different from the previous one. So it's going to be almost exactly the same. Again, I have like here response observer, and I'm just going to say, let's just create a for loop for int e null. So let's just send 10 messages. We're going to just send response observer on the next. Let's say notification. No. Ooh, where the hell you came from? This is not no notification, right? Notification, yes, new builder, and we say set message plus e. Let's say set amount. Well, it's going to be 42 multiplied by e because I like 42, and send account, right? Account, and it's going to be request get account. Okay, that's going to be that. What? Yes, get account. Oh, this one is, no, this one is set CC, right? This one. No, oh no, then I have two C's here, right? Account. Okay, then probably, yes, get. Oh no, I don't take the account, I just get request. My bad. Okay, so that's it. And then when I finish all this, I just say response observer, no, response observer on completed. And that's it. So let's see if this is going to work. So I just start my server. Hopefully everything is good. No, there's a problem. It crashed. Does not exist? Come on. Yeah, this one. Yeah, what the hell is this one? You see, when I practiced this, everything was perfect. You know, like I didn't make any mistake. Again, like everybody says, you know, there's like every demo is a good demo, you know, or either for you know for the audience or for everybody. You know? Okay, so this one is running, right? And we now call notification client. So we just run this one. And as you see, everything works. Perfect. So I'm still good. Okay, so I have 4 more messages, 4 minutes. So let's just quickly go and say, okay, like how we would do. So this is the GitHub area, basically where this example is, because I don't think that I'll have time for the rest, unfortunately. There is also example there how actually you do like, you know, multiple messages in one way and multiple messages in a different way. Because if, for example, you know, everybody took a picture? Okay. Because, for example, if you go back to the example that I showed you, okay, there was like, okay, we have like just one user A send money to user B. But what happens if basically user A and user B are in different banks? Well, in this case, we have communication between the banks. And in this case, this communication here would be multiple to the multiple. Actually, I can even show you the code. Actually, let me check. Yeah, I think I have a code in a different one. So let me just go away. I can just spread to the, okay, I'm on a master. Okay, cool. It's master, yeah, this is master. So in the case of this one, what I would actually, come on, it's not. Yeah, so in the case of this one, I will basically have, okay, message for bank transfer, where I will have some message in this one, and then I will also have message bank response. And here I'm using the status. Okay, cool. Which is actually an enum. So you can also define an enum in this way. This is on the GitHub, so you can actually see all this code. So I don't have time to actually write it. And again, you know, when we go back to bank, it's going to be exactly the same. So RPC, bank, and again, we just put stream on one side and stream on the other side, and that's it. So it's very simple to do it. Again, from the service point of view, it's kind of different. So because in this case, I'm going to basically return back a stream observer. And I'm going to actually, which is for the bank transfer, which basically is actually, I'm returning the stream for the information which I'm getting, and I'm getting as a parameter stream observer for the bank transfer response, which actually I'm sending back. So first time when you see this, it's like it's kind of other way around that you would actually think about it, because in my mind at least, you know, it would be more logical at the beginning, like to actually get this as a parameter, basically the stream of the incoming things, and that I send back the stream of the outcoming things. But you know, here it's other way around. So actually, when you're aware of it, it doesn't become that big of a deal. So the first thing that you do is you just say return new stream observer of the bank transfer, and then actually here you write the business logic. Okay, what happens when the message comes in? So in this case, I just send the message back with some, maybe it's success, maybe it's fail. On error, I don't do anything, and in case of uncompleted, you know, I just complete it, and that's it. And then we go to the stream client. Again, the same thing. Basically, I have manage channel. I have async client. In this case, it has to be async because there are like streams going back and forth. And again, you provide as a parameter stream for the basically bank transfer. So the things that you actually are coming back to you, bank transfer response, and again, you add logic. Okay, on next, I just print it. On error, I don't do anything, and on completed, I just say, okay, it should just finish. And you get back basically the stream of the object that you are sending, and then here I just use the for loop to actually send some messages to the server, and I say on completed, and again, I have to wait in the loop because this is main thread and it would work. Otherwise, it would crash. So let's go quickly over summary, because we're almost out of the time. So I talked to you about gRPC, and in a nutshell, it's a remote procedure call with a lot of goodies baked into it. Don't forget to vote. It's a very good thing, and basically, again, I told you about the use cases, so you can use it in case you want to break out the monolith, in case you were building the distributed system with a lot of complexity, but you can also use it in solving very simple problems. You know, like like in this case, we're just very simple, like user A sending money to user B. Keep in mind that if at any point some system needs to talk to the front end, that part can't be done in gRPC. So even if you're building some system for long term and you're building some block, think, okay, is this block ever going to talk to the outside world? If this block is going to talk to the outside world, then that part can't be done in gRPC at the moment. Maybe in the future they add support for the browsers for gRPC, but at the moment it doesn't exist there. Also, I showed you about the internals. So we have like protocol buffer 3, which is protocol, which you use a different one. I talked to you about HTTP2. Again, it helps a lot with your output. And also, I showed you IDL and how we actually write all the code. Thank you. Here are all the resources that I actually used throughout the talk. So basically, here is my GitHub where all the code is already there. There is blog post about the protocol buffer, talk about protocol buffer, official website for gRPC, and basically gRPC implementation of Java. Any questions? Or I think maybe we're out of the time, to be honest with you. We're out of time. So just grab me afterwards and ask all the questions. Thank you very much.